everyone. Myself Prince Yadav. Today I am excited to take you through the fascinating world of embedded system and how can we use them to control a washing machine using the board PIC 16F877A microcontroller. We will cover the basics of embedded system, dive into embedded C programming, explore the tools MP Lab and Pixel Lab, walk through a practical implementation. Let's uh, continue further. Uh, First of all, what is an embedded system? Yeah, this topic I covered. No. First of all, we will check what is embedded system. An embedded system is a specialized computer system designed to perform a specific task combining hardware and software. Example: washing machine, microwave, automotive system. What is the characteristic of the embedded system? Dedicated functionality, limited resources, real-time operation for time-critical tasks. What component used in the embedded system? Basically, a microcontroller or a microprocessor along with some sensors and the software which used in embedded system, which embedded software which often written in the C programming. An embedded system is like the brain of a device we use daily, such as washing machine. It's a combination of uh, hardware and software designed for a specific purpose, unlike general purpose computers. These systems are resource constrained, often requiring real-time responses. For example, in a washing machine, the embedded system controls water filling, washing cycles, and spinning based on a sensor inputs. The core of the system is often a microcontroller, which will be explored next. Now, the next topic is microcontroller. Microcontrollers are compact integrated circuits designed to govern a specific operation in an embedded system. They contain a processor, core memory, and programmable input-output peripherals, making them ideal for a wide range of applications, including automation and control systems. Generally, a microcontroller is a compact integrated circuit with a processor, memory, and input-output peripherals. In this implementation of washing machine, we using the microcontroller PIC 16F877A. PIC 16F877A microcontroller is generally a 8-bit microcontroller from Microchip technology. In this 8K flash program memory, 368 bytes RAM, 256 bytes of EPROM are present. In this 33 input-out points, 10-bit ADC, timers, UART, and more are present. This is ideal for embedded applications like washing machine control. Uh, PIC it's 16F877 is a popular choice due to its versatility. It's an 8-bit microcontroller with enough memory and input-output pins to handle complex tasks like controlling a washing machine. It can read input from the sensor, process them, and control outputs like motors or pumps. Its rich set, including analog to digital converter and timers, make it perfect for our project. Now let's talk about the programming language we will use, that is embedded C. Okay, overview of embedded C. Embedded C is a set of language extension for the C programming language specifically designed for the programming embedded system. It provides the facility to manipulate hardware in an efficient manner while retaining the flexibility and usability of C. Embedded system is the core language for programming microcontroller because it allows precise control over hardware with minimal overhead. We will use embedded C programming to program our washing machine's control logics. To do this, we rely on tools like MPLab IDE, which help us write and compile code, and the X8 compiler, which translate our C code into instruction. The PIC60F877A microcontroller can understand. Let's explore these tools. Just a second. Mm, So the next is programming microcontrollers with MPLab. MPLab is a comprehensive development environment used for programming microcontrollers. It provides tools for writing, debugging, and testing embedded programs written in C or assembly. Leveraging this environment facilitates a smooth development process, ensuring the robustness of applications. MPLAB XID is our primary tool for the developing embedded C code for the PIC16F877A. It's user-friendly with features like code debugging and simulation. PixelLab, on the other hand, is a fantastic simulator that lets us to test our code virtually. We can connect virtual sensors, motors, and display to the PIC16F877A in PixelLab, ensuring our code works before we build the actual hardware. This saves time, money. Now let's see how we can apply these tools to design a washing machine control system. So for washing machine, what are the system design and requirement? We are going to see the next. Designing a washing machine control system involves defining an operational requirement and constraints. Key aspects include managing motor controls, water level, cycle timing, and user interface interaction. Properly outlining the element ensures functionality and reliability. A washing machine is a perfect example of an embedded system. The PIC16F877 microcontroller reads inputs from sensors like water level or temperature and user inputs like water level or temperature and user inputs from buttons to select wash cycle. It then controls outputs like the drum motor, water pump, and valves. For example, the ADC module converts analog sensors signals into digital data, while timer ensures precise control of wash, ride, and spin cycle. Let us dive into how we implement these using the embedded C, MPLab, and PixelLab. So, using Pixel, let us take a simple implementation. The PIC16 F877A board is connected to a water level sensor and analog input pin and control a motor and pump where relays are would be. This code simulates the water level using the ADC. It starts the motor. If the water level is sufficient, runs a 5-second wash cycle and then drain the water for 3 seconds. In PixelLab, we can simulate the setup by connecting virtual component, testing the logic without hardware. Then once verified, we use a programmer like PIC kit to upload the code to the PIC16F877. This approach ensures reliability before building the physical system. Now, developing software using PixelLab. PixelLab provides user-friendly platforms for developing software for PIC microcontrollers. It enables the creation of flowcharts and graphical programming. Simply the programming process utilizing these tools enhanced code efficiency and reduced development time for washing machine. machine application. Now let us see the project demo. Now, after implementing the washing machine, we face some challenges like implementing washing machine controller had its challenges like real-time tasks, like precise cycle timing, required careful programming for timers and interrupt. The PIC 16877A limited memory means we must optimize our code, avoiding heavy operations like floating point math, simulating pixel lab helps catch logical errors and testing hardware step by step ensures reliability. These practices make the development process smoother and more efficient. Now we are coming to the end of this presentation. So now I am going to conclude this presentation. In summary, an embedded system leverages the power of microcontroller to perform specialized tasks such as in washing machine understanding embedded C microcontroller architecture and the software development process with the tools like MPLab and Pixam Lab are crucial for developing an effective control system. The Pixam 16F877, a microcontroller, is ideal for controlling devices like washing machines, embedded in MPLab IX, IDE, and the Pixam Lab enable efficient development and testing. The washing machine project demonstrates the practical application of these concepts. Future application of these expanded to IoT-enabled washing machine with remote control, integrate machine learning for adaptive wash cycle. To wrap up, embedded systems are the backbone of modern applications and the PIC16F87 program in embedded C is a powerful tool for building them. Using MPLab and Pixam Lab, we can efficiently design and test a washing machine controller. This project is just a start. Imagining adding IoT features for remote control or machine learning for smarter cycle. Thank you for your attention. So, thank you. And I would like to thank Emertex technology for this insightful, this learning internship, which helped me to understand a lot of things in this embedded system, which I'm going to implement in our further upcoming projects. Thank you once again.